Hello everyone, Joe from Central Jersey Conrail and N-Scale. Welcome back. This is episode 18. This episode we're going to be focusing on the construction of the Essay interlocking and associated control panel. So let me start off by saying that this project here was one of the more involved projects of this layout thus far. We incorporated a lot of different systems into this control panel. We have a closed circuit TV camera system. We have a Digitrax BDL168 block detection unit. We have a computer interface, and we have the control panel with signals and turnouts. So consequently, this construction has taken some time. I think I've been working on this consistently now for 4 weeks, and there was tons of video footage. So I sat down and started looking at all the video footage, and unfortunately what was going on is I was too engrossed in my work and not really paying attention to my camera. And a lot of the shots I was blocking, or the areas that I was shooting in was too confined, and just some of the footage was just me soldering, and watching me solder is about as thrilling as watching paint dry. So a lot of that footage I just ended up cutting out, and I did get some snippets of some key processes that we can show you. So for this episode, what I'm going to do is it's going to be more of like a walkthrough tour. I'm going to show you the three major components of the interlocking, and that's number one, the track structure itself, number two, the block detection system, and then number three, the control panel. So why don't we get started, and I'll show you the actual track. Okay, so this is how the junction itself actually came together. So if you notice in the back corner over here, what I ended up doing is I had to cut the hole a little wider and ran the track out this way. This is a 13-inch radius curve, and then this curve over here is actually somewhere in the vicinity of a 15-inch. I think it might even be like 14 3/4. Then in the back corner, here's one of our cameras, and this is the other camera here. Once we come out of the Y here, it goes into our base level of our helix. So we're already set to go on the first level of our helix, which will be next episode. So for the Y, this section here is actually the reversing section. The reason I put this section as on the reverser is because I believe that this is going to be the least likely used reversing section. So trains that come through here won't actually be reversing. The reason I did it that way is because if you have a train, let's say if you have a series of locomotives, say we put 5 or 6 locomotives on one train, and they enter into this section, they have to all fit in the reverse section at one time. Another example would be if you had passenger cars that are powered. So the train would be longer than the reversing section. So this way it would kind of prohibit me from running long trains with big consists or any kind of power cars or anything like that. So that's why I went with this section for the reverser, because at this time I'm pretty sure that's going to be the least likely use. So with that being said, this leg here is to simulate traffic in a southbound direction. So this would be trains coming from Newark going to Brown's Yard. This leg over here is to simulate northbound traffic, so trains coming from Camden to Brown's Yard. And then this is my north-south connection, so it's just a turning portion. So the reason this is here instead of just eliminating this and just making trains go this way or this way is so that I can establish my continuous run. So on days I don't want to do operations, I can just have the trains come in and do the continuous run throughout the layout. So consequently, I've called this the north leg of the Y. This is the south leg of the Y, and this is the north-south leg. So that'll be important for my labeling purposes when we get into our block detection system. Okay, so if the track is the bones of the Essay interlocking, this is the brains. This is the BDL168. So the first thing what I did is I mounted the BDL on a sheet of plywood, and then all the associated equipment also went on a sheet of plywood. I did that because I didn't want the card hanging out in outer space. So the major components down here, that the BDL168 block detection card. This is the AR1 auto reverser. I use some European style terminal connectors, and then I have just a standard terminal bar over there. Power comes in from the DCC system here, goes out to the card. These are the track sections coming in, the power going into the track sections, and then these rainbow ribbon cables here are the output signals for the block detection card, and I'm using that to drive my LEDs on my control panel. So before I started constructing this whole panel, what I did is I did a simple line diagram of where I wanted the components and where I wanted the lines to go, just to give me a guide as I was assembling it, just to make construction a little easier. Now, after I did all this work, I was on the Facebook forums, and I found out that they actually have what's called a breakaway panel made specifically for the Digitrax BDL168s. And it's kind of like a giant circuit card that eliminates having to do all this. And because from Digitrax, they only put those pin connectors in, you get that blue edge connector, that's it. So with the breakaway card, you just insert this card into this giant PC board, and then it has all screw terminals for all this wiring that I actually built. The other component down here, this is the Digitrax AR1 auto reverser, and that's what controls the auto reversing section in the Y. I have heard a lot of people out there who have complained about the AR1. So far in testing, I've not run into any issues. I didn't have to do any kind of tweaking on the settings. Pretty much I just wired it in, and it's running so far fine. I've run numerous trains through. I'm just wondering if the problem will arise if I start adding, multiple unit consists, but we'll see. You can see that the local net comes into the top here on this portion here. Digitrax does recommend that the BDL be the last thing on the string. They said that it works better that way, so I kind of took the lead from Digitrax, and that's why you only see one local net cable coming in and nothing going out. So the BDL is broken down into 4 zones. That's why you see these 4 black blocks. They have something to do with the current sensing. I'm not too up on it, but I know that that's what those are for. And then there's also the 4 output sections. So zones A, B, C, and D. And then each zone has 4 sections. So that can give you up to 16 blocks on this block detection card. So what I've done is zone A in this group here is for the mini helix, the big helix, and the return loop. Zone B would be the north and south legs of the Y. And then zone C is the auto reverser. So now you can put an auto reverser on this card, and that's why this auto reverser is tied into zone C. However, with this card, you have the zone will be the auto reversing zone. So that means that you can't have the auto reversing section on one zone and then the other 2 legs of the Y. They have to be separated out. So that's why zone C is just the auto reverser. Now these ribbon cables, this is actually a product I got from DigiKey. It's made by 3M. Digitrax recommends it because it's got this nice little connector. They're all pre-made up, and you just put it right onto their jumper board. And then I brought all the cables down and tied them in. And then what I used is all this white cable is phone line cable. So I used it because it had multiple colors inside there, and I used the phone line cable to send the signals to the LEDs at the control board. Okay, so I've gone ahead and powered up the card. So the card uses 2 power sources. First, you need a 12-volt power system. They recommend using the PS14. According to the directions, Digitrax is saying that it needs to have its own designated power supply. But I went ahead, I'm just doing a little test here, and I tied it into a 12-volt bus. And that's what the red and black wires are. So far, I have not noticed any anomalies in the card due to any kind of fluctuation in voltage. And right now I'm looking at my panel. I'm running at 11.9 to 12.0 volts, and the amperage fluctuates between 1.09 and 1.06. So there is a little bit of fluctuation, but the card's been acting properly so far. If there's any issues in the future, I'll just take it off the 12-volt bus and then use a designated power supply. So if there's any problem arises, I'll make sure to point that out to everybody. Okay, so the way that the Digitrax BDL168 works is what you have to do is off of my booster is on the Digitrax system there's an A rail and a B rail. So the BDL168 functions on the power from the A rail. So if you look down here on this terminal strip here, you have the A rail power coming in from my booster. It's just coming off the booster because these sections here are on my second power district. So that's why I'm not bringing it directly off of the command station. So the power comes in from the booster, and then it's broken out, and that's what the white wires are going into the edge connectors. That's power, the A rail in. And then what happens is the A rail comes back out of the card, and that's what the green wires are, and then goes out to the various rails on the different sections. You don't bring the B rail into the card. And then with the auto reversing section, A rail power comes in, and then it goes over to the reversing card, and then it goes back out to the detection card in the zone C, and then it comes out on the green wire, and then it goes back out to the reversing section. Now the key, and this is very, very important. If you don't take anything away from this this whole section, the very important part of this that I can relay to you is that yellow wire. That yellow wire is the ground wire, so that has to be run back to your booster and tied into the ground. Now, the edge connector has 2 rows of pins. There's the lettered pins and the numbered pins. As you're assembling it, every single wire goes through both the A pin and the number 1 pin, and the B pin and the number 2 pin, and they have to get to both rows and get soldered. The only exception is that ground wire. That only goes to the M pin. So what I did is I tied it into the M and whatever the associated number was, and I soldered them both. So when I powered up the card, it just was not functioning. The whole DCC system wasn't functioning. It was like in total lockdown, and I could not figure it out. So I went to online and I found out that I had done it wrong. And then I went back in my directions and I had seen where it actually says right in the directions, only the M pin. So what I had to do is I had to come in and cut the pin and then powered it back up and everything worked. So just remember that if you're going to use this card and you're setting it up, your ground wire only goes to the lettered pin, not the numbered pin. So far the BDL is very user friendly. There is some adjustments. You can adjust the sensitivity and the sensing, but pretty much there's no programming when you're setting up your block detection card. It's all pretty much wiring. So that's what made it fairly easy. The one thing I did do is you can assign address to your BDL cards. And that would be for if you're doing a large layout with multiple BDLs, you can label them. So this block here I labeled 001. It's the first one, and it's probably going to be the only one, but if there arises a need in the future, I can just make the next card 002. Okay, so there is the BDL168 and all the associated equipment. So it's all powered up. Let's go over and I'm going to show you on the computer what I've done with my Panel Pro. Okay, so we're over here at my trusty antique computer. I apologize that I have to do it this way, but I just cannot get my screen capture software to work on this computer. It totally crashes the whole system. So what we'll do is we'll make do with what we got. So this is Panel Pro. It comes with your JMRI software package. I used an editor just to create a basic panel. I didn't put it. You can get real fancy. There's guys out there that know how to use this program that can make like track diagrams and stuff like that. But for my purposes, I just wanted a simple black panel like this with just sensor lights. So you can do that through the editor. And what it does is when each section is not occupied, it's the gray color, and then when it's occupied, it's yellow. So right now the big helix is occupied. So if I trigger the system here, the mini helix is now occupied, and then it's not occupied. So and you can see on the bottom there I have the LocoNet window also open, and you can see the different zones telling the system that they're occupied or not. So I do have to point out that in order to make this work on this computer here, you do have to attach your Digitrax system to the computer, and I'm using the PR3, so that enables me to do this right on the computer. So this is just another nice little function, so you know, I can see graphically here in the layout room when the different sections are occupied, because all of the indications is on the panel in the staging yard. So now let's head over and go take a look at the panel. Okay, and so I present to you the Essay interlocking control panel. So what we have here is on the left, this is the Bunker Hill security camera system that controls the 2 cameras. Across the bottom here we have the 3 rotary switches, and that is for all the signals. And then I have a graphic representation of the area that we're controlling. Again, with all the other panels that I've constructed in this panel, I've kept with the color schemes just so there's uniformity. The amber is indicating that the panel has power. The white is indicative of block detection, and when it's on, it's indicating that the section is occupied. And then I have the red and green LEDs up top, and that is for my turnout positions. Green being the straight through route, and red being the diverging. On the bottom here with the rotary switches, when I first put them in, such as this one here in the middle, they worked fine. But what I was having the issue was when I first installed the dwarf signal, which is signal 001, I had to constantly look down to make sure that the signal was at the proper aspect. So I got to thinking, and I'm like, well, you're not going to be able to do that with signal 67 because that's all the way inside the layout room. So then what I decided to do was put in the LEDs to indicate it's kind of like a remote indication to tell you what the semaphore is, what the aspect is. So if I go here and turn it that way, now signal 67 is indicating an approach. And then if I go to the next position, signal 67 is indicating a clear aspect. So some questions have arisen in the past is how I'm building my panels. So this panel is constructed of 2x2s, and then it's attached to the wall. The black portion that you see is actually acrylic. I just got acrylic plexiglass from Lowe's. And then what I do is I paint it kind of like you would an RC car body. The dark color first and then the light colors last. And what I do is I use auto pinstriping to mask off the track diagram. Then I paint the black, pull off the pinstripe, and that leaves the exposed areas that I want white, and then I paint it white. And that's how I put the panels together. Another question that keeps arising is why do I put the key switches in? So initially, the key switches started out was for the staging yard panel. I kind of wanted to just, add a little function to the staging yard operator just to make it seem like a little more realistic, having to power on the panel and power off the panel. Also, the big thing was, I was thinking about open houses. So if I have an open house, what's going to keep, little fingers from manipulating turnouts and then, throwing off the position of the turnouts, and operators, don't notice it. So that's when I was like, well, if I could lock the panel. So, if there's an open house going on, I can set the turnouts and then turn the power off to the panel. It'll hold the position of the turnouts will still be there, and then the panel's locked, and I can take the key out so nobody accidentally manipulates a turnout. The other function that was kind of like a secondary, byproduct was, let's say we have a big operating session going on and something goes haywire in this one panel here, an SA control panel. How would I be able, I don't want to have to shut down the whole 12-volt bus because then all the other associated panels will be offline. So for troubleshooting purposes. So this way I can power down just this panel if there's a problem in this panel, open it up and try and fix it during an op session, and the rest of the layout can continue to run. So that was kind of like a secondary function of the key. Okay, so here's the inside of the SA control panel. The white lines that you can see coming in, those are all of the telephone lines. The telephone lines are for two purposes. One is for the signals in from the BDL168, and that's this European terminal strip right here. So then that goes out to the white LEDs on the panel. The second European terminal strip that you see here is for all the signals, and that's getting power from the rotary switches and sending signals out to the signals on the layout. Okay, so these two terminal strips here on the bottom, that's all my power distribution blocks. So power comes in from the 12-volt system and then goes out to the associated items on the panel. So these are the rotary switches for controlling the signals. As you can see, there's also the LEDs. They're also tied in for indication of the position of the rotary switch, as well as sending signal out to the signal heads. There's the key switch and the amber LED. And this mass of wires here is for the turnout control and indication of position. That braided wire that you see there, I actually made myself, and that is the power coming out for all the LEDs for the occupancies. So when I was constructing this panel, I was attempting to keep it as neat as possible, but as you can see, you know, it does look a little like a bird's nest. But I did bundle everything together so it's in groups. So just to make it a little easier for troubleshooting, I tried to, you know, but there was just so much I was cramming into this panel that it kind of just overwhelmed me. But yeah, it is what it is. I made sure to label everything and then, you know, just keep it all nice and neat. Okay, and then so as trains enter the circuit, each circuit, it'll indicate by turning the block detection light on and off. So that's how that looks when that happens. And also what I found out that is you know, after testing, I did not have detection lights on the panel for the legs of the Y, but then it just got confusing when I was trying to figure out where the trains were, because, you know, I kind of lost them for a few moments before they would come on camera and all that. So that's why I went back and installed those white LEDs for the legs of the Y. Okay, so the last little portion I'm going to cover on this panel before we start showing you how it works is the signals. So there's 3 rotary switches there. I labeled the one that I don't know if you can see because of the glare is signal number 67, and that's because it's located at milepost 67 in Lakehurst. And then signal 001, and that is the dwarf that is located in the staging yard, and you can see it right down there. And then this third rotary switch is going to be for the signal that'll be located at the top of the big helix, and you can see right there in the center of your screen, that's going to be where that is. So now let me preface this by saying, no, I am not going to be installing signaling on the Sayrehurst Secondary, because the Sayrehurst Secondary, we're going to be sticking strictly with the prototype, and it's going to be dark territory. These signals were installed specifically for during op sessions so that the panel operator can control the traffic flow on the hidden loops. So this way we don't have one train coming from Camden that's going to interfere with the train that needs to go to Browns, and so he can control the traffic flow locally. And that's all those signals are for, is just to indicate occupancy of the block ahead. Now, I could have tied the signal into the block detection card to just automatically output the signals. However, I wanted the operator to be able to control it so that if even though the block's clear, he may not want a train to proceed out of Lakehurst at this time because maybe he has something in the staging yard that's coming up. So that's why I put it in as manual control. Now, so this is an interlocking panel. I know that there is no interlockings installed. So there's no electrical interlockings and there's no mechanical interlockings. So consequently, if the panel operator could accidentally route trains against each other. So that's just going to have to be something that the operator's just going to have to be trained and make good decisions so that we don't have any incidents throughout an operating session. Okay, so what you're looking at is signal 67. That's right in Lakehurst. It's the controls the entrance to the mini helix. And if you see, you know, this is what it looks like. That's the approach, and this is the stop aspect. So I'm just doing that by rotating the selector rotary switch on the panel. Now, these signals, actually I've had these for a long time. I believe they're old NJ International semaphores. And what I ended up doing was, here in Lakehurst, I went with this style of signal because the CNJ had this style of signals on the Southern Division main. So that's why I went with this. Okay, so let's do a little demo here. So this is what the panel looks like. We have a train coming off of the big helix. It needs to proceed through the Essay Junction, head to the return loop to head up to Lakehurst. So I've already gone ahead and selected the route. As you can see, the red and green are indicated for the turnout position, and we can see that in the camera I have the train all set up to go. So we're just going to start moving. And as you can see, it's entered the north-south leg of the Y. So now what I have to do is I have to change my camera angle. And we can see the train clearing the position here with the camera and heading out onto the return loop. And once it clears, there it is, entered the return loop block, and it's cleared the north-south leg. So now currently right now I'm not running any of my cars with resistor wheel sets. And if I did have resistor wheel sets, you know, the north-south leg would be indicating and the return loop at the same time. Right now I'm just using the locomotives to detect blocks. Because, you know, at this point it's not all that important. You know, we're not basing all of our train movements on where the train is. We just need to know that general vicinity of where the train is. Okay, episode 18, Essay Junction, completed. Yes, every episode I surprise myself more and more with the more complex projects that I'm taking on and how well they're coming out. Essay Junction has exceeded my expectations yet again. You know, with Essay Junction, it seems like a lot of overkill. This is not going to be an area that's going to be visible. It's all going to be buried underneath the big helix. But I thought it was vital to the operations to get trains out of the staging yard and be able to go southbound to head to Browns Yard and simulate traffic from Newark to Browns. And also to get trains out of the staging yard going northbound to simulate traffic coming out of Camden heading north to Browns Yard. I thought it was very vital to the whole picture here on the Sayrehurst Secondary, and then also that north-south leg allows now trains to do a continuous run. So once the main line is completed and linked up down in Monmouth Battlefield State Park, we'll be able to let trains just run around the loop without any intervention. So just to go over, we went over the BDL168 made by Digitrax for the block detection. We also touched briefly upon the Digitrax AR1 auto reverser. I showed you the Panel Pro panel that I made up for indication of the blocks and which is occupied and what is not. And the panel, yeah, the panel is very complex. There's a lot of information there on that panel for the operator, whoever is controlling that interlocking, to make the decisions that they need. And like I indicated, there is no mechanical or electrical interlocks, you know, to prevent accidental routing of two trains into each other. But you know, I just, that was more electrical work that it was kind of above my abilities, and I didn't want to cram too much into that panel. Now looking back, there are a lot of products out there that would have been able to make this junction a true interlocking. You know, we could have used the SEC8 from Digitrax in conjunction with the BDL168 to make it a true interlocking. But from what I'm reading, and I don't quite understand, maybe someone out there can tell me if I'm wrong, but from what I was reading, there is no manual control over the SEC8. It's all done through the computer, so you couldn't have a locally operated panel for an operator to make the decisions. And my personal preference, and it's just the way I like to operate, is I don't like using my throttle to go into the switch feature to select switches, to move the switches. I want to reach out there on the panel, I want to grab a toggle switch and move it and watch the turnout move. I don't want to be fumbling through menus on my throttle to position turnouts. So that's another reason I'm kind of shying away from the SEC8. There's also other products out there. JMRI makes a whole product line of computer-controlled CTC products that would be able to allow you to make it a true interlocking. You know, but that's all computer-controlled again. And there is some associated panels with the CMRI system that you can put panels in to override and do manual controls. But, you know, I didn't want to invest heavily in that because most of the layout is dark territory, and I didn't see the benefit of starting to install the CMRI products when I'm not doing a full signaling system. Okay, so now where we're going. There's just a few more things that are left here on the SA control panel. One, I got to dress it up with the masonite on the sides, but I'm not going to do that until I start doing facial work, because I don't want to pull all that out and start doing, you know, a lot of stuff. I'll just do it when I'm doing the facial for the rest of the layout. I'll just go in and dress it up. Okay, so just just give everybody an idea where we're headed. Next episode, episode 19, we'll be putting up the big helix. After that 19 and a half, I'll be showing you all the mock-ups for the buildings for Englishtown, Jamesburg, and the engine facility at South Amboy. And then episode 20 will actually get started on connecting the main line from the Helix all the way down to Battleground State Park. So this way you just have an idea that where we're headed. And I'm really pushing hard on this timeline to get this done by the first week or so in summer. So, looking at a June time frame to have the main line up and running. And then we'll work through July on building Brown's Yard. So really itching to get that done too. Okay, so thanks for watching. If you are a first-time viewer and you like this video, make sure you subscribe to our channel, Central Jersey Conrail and N-Scale. And thanks for watching, and we'll see you next time.